In this video, we'll be looking at how to use index laws in order to simplify and calculate questions. How to calculate integer powers, how to calculate indices using a calculator, how to calculate both fractional and negative powers, and then we'll be looking at some exam questions where we're asked to simplify expressions which are using powers. Before we go further, we need to clarify the difference between simplifying an expression and evaluating it, as this comes up quite a lot when dealing with indices. If we take this example of 2 to the power of 5, this is a simplified expression, as is the next one, 5 to the power of 2. As we know what the base numbers are, the integer value as opposed to the smaller power number, we could also go on to evaluate them. 2 to the power of 5 equals 32, and 5 to the power of 2 equals 25. So evaluating means calculating the numerical value of the answer rather than leaving it with a power. So let's look at some examples of the different types of powers that we'll be looking at in this video. First of all, we have 4 to the power of 1. And whilst this may seem unimportant, it's worth pointing this out now before we look at calculating with powers, as it's often overlooked that every number has a power. If you can't see one, it's got to be assumed that the power is 1. Next, we have 4 to the power of 2, which we call 4 squared, as this refers to finding the area of a square. This means there are two 4s being multiplied together. So 4 squared will equal 4 times 4, which equals 16. Now we have 4 to the power of 3, which we call 4 cubed, as this refers to finding the volume of a cube. This means there's 3 4s being multiplied together. So 4 cubed is 4 times 4 times 4, which equals 64. 4 times 4 equals 16, 16 times 4 equals 64. Next, we'll look at some buttons to use when dealing with indices and how to use a calculator to help calculate them. On the calculator, we've got several buttons we're going to be using when dealing with powers and roots. So if you're trying to find the power of 2 of something, you can use this button, which is a power of 2 button. If you're trying to find the cube or the power of 3 of something, you can put the integer in and then press this button, which is a power of 3 button. If you're trying to find any other powers, including negative powers, you can input the integer and then press this button, which is what we call an other power button. If you're trying to find the roots of something, for a square root, you can put in this button, which is called a square root symbol, which we'll be coming to later on in the video. If you're looking to do a higher power, you can press Shift and this root button, and then input both the power and the integer that goes underneath it. Lastly, if you're trying to find a fractional power, if you press this button for other power, and then the fraction button, you can input both. As you can see, it's possible to use the calculator to deal with evaluating many of the powers that you're going to come across. However, it helps to understand that methods that are used to simplify problems that use powers, as many exam questions ask for this. On this slide, we'll look at how to deal with powers in several operations. In all of these, we are being asked to simplify them rather than evaluate them, so we'll be leaving them with a base number and the appropriate power that would allow you to calculate the value of it at a later point. The first problem is 4 to the power of 2 times 4 to the power of 3. So that's 4 times 4, and then 4 to the power of 3 is 4 times 4 times 4. Have you noticed we're multiplying these two sets of powers together, so we'll put a multiplication symbol in the middle. So you can see now that we've got 4 times 4 times 4 times 4 times 4. So it's 4 to the power of 5. And the way you can think about that is you can actually add the powers together because the base numbers are the same. So you have 4 to the power of 2 plus 3 gives you 4 to the power of 5. So in multiplication with indices, it's important to remember that if the base numbers are the same, in this case the number 4, you can add the powers. So here we have 4 to the power of 3 divided by 4 to the power of 2. So that's 4 times 4 times 4 divided by 4 times 4. If you can remember in the fractions video, anything divided by itself is 1. So this first 4 on the top and the first 4 on the bottom cancel each other out, as do the second 4 on the top and the second 4 on the bottom. And we're left with 4 to the power of 3 minus 2, which is 4 to the power of 1, or we can simply write 4. In division, it's vital to remember that if the base numbers are the same, you can subtract the powers. In the final example on this page, we've got to deal with powers of powers. And we have a problem of 4 to the power of 2 in brackets to the power of 3. So we can write this out to be 4 to the power of 2 times 4 to the power of 2 times 4 to the power of 2. And we know how to deal with this one because we've looked at multiplication before. We can just add the powers, 2 plus 2 plus 2. We could also think about multiplying the power inside the bracket by the power outside the bracket to give us the value of 6. So we've got 4 to the power of 2 times 3, which gives 4 to the power of 6. When dealing with powers of powers, you can simply multiply the power outside the brackets by the power inside. Next, let's take a look at fractional and negative powers. Firstly, we have 4 to the power of negative 1. Now, it's important to remember that negative powers don't necessarily mean negative numbers, but that the results will be really small numbers that are represented by fractions and can be converted into decimals. So 4 to the power of negative 1 is going to be 1 over 4 to the power of 1, or 1 over 4, which can be converted to the decimal of 0.25. So next we have 4 to the power of negative 2. So again, we can write this as a fraction under 1. So we have 1 over 4 to the power of 2, which will equal 1 over 16, which will equal the decimal of 0.625. The last fractional power will show how small these can get really quickly, as we've got 4 to the power of negative 3, which means 1 over 4 to the power of 3, which is 1 over 64. And we can convert this to the decimal of 0.015625. You can see by this how we can get really small numbers quickly in the space of just a few decreases of power. Now let's move on to fractional indices. Here we've got 4 to the power of a half. Whenever there's a fractional power, we're going to make use of the root symbol. Many mistake this as a square root symbol, which we assume it is unless we see another small number outside of the root symbol. Fractional indices are the way of writing roots as powers. So 4 to the power of a half, the denominator of the fraction is the actual root we're trying to find. So we'll place that number outside of the root symbol. We'll put the integer underneath the root symbol with the numerator as the power of that integer. So now we've got the second root of 4, or the square root of 4. And remember, this can be both positive and negative too. It's handy to remember that the power of a half is just the square root of that number. It's surprising how often this comes up. Next, we're stepping up the level of complexity with 64 to the power of 2 over 3. So 64 to the power of 2/3. We use the denominator as the root we're trying to find, so we'll place that outside of the symbol. We'll write the integer 64 underneath with the numerator as the power. Remember, it's always worth trying to find the root first before you find the power. So the third root of 64 is going to be 4 to the power of 2. And we can evaluate that to be 16. Remember, it's always worth trying to find the root first before applying the power to the integer. Now we'll look at combining negative and fractional indices with this question, 125 to the power of negative 2/3. As it's negative, let's write our fractional power under 1 using the root symbol. So we're going to write 1 and then a root symbol underneath it. Underneath the root symbol, we're going to put the 125 because that's the integer. The denominator of the fraction is the 3, so we'll put that outside of the root symbol. And the 2 is the power, so we'll put that inside and over the integer. The cube root of 125 is 5, so we do 1 over 5 squared. 5 squared is 25, so our final answer is 1 over 25. So 125 to the negative 2/3 is going to equal 1 over 25. So remember, negative powers go under 1 as a fraction, and fractional powers needs the use of the root symbol. Always try and calculate the root before the power to save dealing with really large numbers. Here we have some more advanced indices that we're being asked to simplify. Remember, when dealing with variables, which tend to be represented by letters, in between each term is multiplication. If we expand the expression, we would get 4 times x squared times y cubed times 2 times x cubed times y squared. Now we can rearrange this to give us 4 times 2 times x squared times x cubed times y cubed times y squared. 4 times 2 will give us 8. X squared times x cubed will give us x to the power of 5. Y cubed times y squared will give us y to the power of 5. This can be simplified further by taking out the multiplication symbols to give us 8, x to the power of 5, y to the power of 5. This is as simplified as we get, as we don't know the values of x or y. Remember, when the base numbers are the same, you can simply add the powers when multiplying. In the next problem, we have to remember that when dividing with powers of the same base number, we can subtract them. So we can rewrite this as follows. So here we've got 24 x to the power of 5, y to the power of 6, over 4x, y to the power of 3. So we can split these out to be 24 over 4 times x to the power of 5 over x times y to the power of 6 over y to the power of 3. So if we calculate what those are using our index laws that we've covered, we have 24 divided by 4, which gives us 6, x to the power of 5 divided by x, which gives us x to the power of 4. Remember that x has a power of 1, even though we haven't stated it. Y to the power of 6 divided by y to the power of 3 will give us y to the power of 3, because 6 take away 3. So now we've got 6 times x to the power of 4 times y to the power of 3. We can just simplify that further by taking out the multiplication symbols and get 6 x to the power of 4, y to the power of 3. In the next video, we'll be looking at how to write numbers in standard form and how to convert standard form to ordinary numbers. It uses a lot of the index laws that we've been covering in this video. Then we'll look at how to do calculations with them, and I'll see you then.